Welcome to Chapter 3, Section 4, Exponential and Log Equations. We're going to continue talking about exponential functions and log functions. So our central question is, how can we model real-life situation with log equation? So, solving exponential equations by expressing each side as a power of the same base. So this means you have the base m, and you just have different exponents. That means if these two are equal, m and n are also equal. So your first step is to rewrite the equation in the form with the same base. Set m equal to n and solve for your variable. So if we look at this, let's do the first one. So 5 to 3x minus 6 equals 125. You know you have to have the same base. So 5, you want to think to yourself, 5 to what power gives you 125? In this case, it's 5 to the third power. So step 2 was to set your m equal to your n and solve. You have x equals 3. Your next one, you have a little bit more that you have to do. You want to think, what is the same base that these two can have? In this case, your same base is going to be 2. So you have to convert both of these so you have 2. So you want to think, 2 to what power gives you 8? You have 3. 2 to what power gives you 4? And it's 2. So now you have them equal to each other, and you have the same base, so you can set them equal to each other. And just solve for your x now. So in the questions and on the test, you want to say what your solution set. And you just write it like that. So your first step is to get them in the same base, set your exponents equal to each other, and solve for your variable. So using logs to solve exponential equations. First thing you want to do is isolate the exponential expression. Take a common log on both sides of the equation for base 10, or take the natural log. Simplify using one of the following properties. So these are the properties we talked about before. And then solve for your variable. So let's look at this example. 5 to the x equals 134. So this means if I take the natural log, on both sides, you want to simplify that now. Now if I'm just solving for the equation, that means I can divide both sides by my ln 5. So I have x equals ln 134 over ln 5. Once you plug that into a calculator, you'll get that this is about 3.04. So depending on how the question has their answer phrased, your solution set can be ln 134 over ln of 5. Or it may be set up as 3.04. It all depends on their preference at the time. So let's look at another example. We have 10 to the x equals 8,000. So in this case, we're going to do a log. So you're going to do the same thing. I take that back. You're not going to do the same thing. You want to think, you have log 10 to the x. This is a special rule. So remember, you have log 10 to the x equals b. That means x equals b. So now we're just going to have log, or x equals log 8,000, which is about 3.90. So our solution set is log 8,000 or 3.90. So you want to remember your rules from before, so this is a special case. So our next problem, we have 3 to the 2x minus 1 equals 7 to the x plus 1. This one we're going to do similar to what we did in the first equation where we take the ln of both sides. Now you want to think about your rules for this type of problem. So this really means I have 2x ln 3 minus ln 3 equals x ln 7 plus ln 7. You want to get all of your x's so they're on the same side and all of your non-x's on the same side. So that means I'm going to subtract my x ln to the 7, or x ln 7, and move it, and I'm going to add my ln 3. So that will end up with originally simplified. So you're going to get your solution set next. So if I want to get rid of whatever's attached to my x, I have to divide by it. So that means I'm going to have ln 7 plus ln 3 divided by 2 ln 7, or 2 ln 3 minus ln 7. Make sure you complete the questions below and then watch the next video. Next class we're going to talk about logs to solve logs.